Hi all, Happy New Year 2024. Today's Geeksforgeeks problem of the day is array pair sum divisibility problem. Given an array of integers nums and a number k, write a function that returns true if the given array can be divided into pairs such that the sum of every pair is divisible by k. Example 1. Nums is 9573, k is 6, output is true because we can make pairs like 93 and 57. 9 plus 3 is 12, which is divisible by 6, which is k, and 7 plus 5 is also 12, which is again divisible by 6, so output is true. In second example, the number of items in the nums array is odd, so there will be one unpaired 4. For example, if we choose any two number, there will be one unpaired number, hence output is false. Our task is to complete can pair method, which takes the array nums and k as input parameters and return true if the array can be divided into pairs such that the sum of every pair is divisible by k, otherwise return false. Expected time and space complexities are O of n. Constraints for everything is up to 10 to 10 to the power 5, actually between 1 and 10 to the power 5. So even if we assume that these expected complexities are not mentioned, it is worthless to try the brute force solution of n square complexity, which is of doing two nested loop. Although the other solutions like O of n log n solution can still pass in the time limit, but since the expected time and space complexities are O of n, let's go with the optimal solution. The idea is to keep the count of num mod k for each num in the nums array and then check if its count equals to the modulo complement count, that is count of k minus num mod k, and then mod k to the whole value. This mod k to the whole value is only necessary when num mod k is 0. For every other cases, this value will be less than k and it will always equal to whether you are putting mod k or not. So in okay, so other than checking the count of num mod k and the count of complement of num mod k, we also need to handle two special cases when when num mod k is 0 and when num mod k is k by 2. This second condition only needs to be checked when k is even. In these cases, actually, modulo and modulo complement will be same. For example, suppose num is 24 and k is 6. So in that case, both num mod k and k minus num mod k and then whole of mod k will be 0. And suppose k was suppose num mod k was 3 and k is still 6, then 6 minus 3 mod 6 will be equal to 3 and 3 mod 6 will equal to 3 as well. So both the modulo and modulo complement are same. For making a pair, we need at least two numbers. So for these two special cases, we additionally need to check whether these counts are even. So that's what I checked here. Okay, before that, I'm first checking whether the length of the array is even or not. If it is odd, it is just similar to the second example. So we can simply return false here. After that, I'm calculating the count of num mod k for each num in nums. After that, I'm checking the special cases when the num mod k is 0 and when k is even and the num mod k is equal to and num mod k is equal to k by 2. So in these two cases, we are returning false. For other case, we are checking whether the count of I is not equal to count of k minus I. So if that count is not equal, then we are returning false. After returning false for all the impossible cases, we are returning true as answer. This concludes our solution. You can also see that this solution has actually worked because it has passed with 100% accuracy and with a single attempt. And that's all for today's video. Thank you all. Please like, share, and subscribe if this was helpful to you. Bye.